Let's have a quick look at the Coriolis effect. And this video comes with a massive shout out to Nico. Hit me up for any physics or chemistry problems. Which way does the water drain from your sink, or if you care to watch, from your toilet? Clockwise or anti-clockwise? Here's the thing, it has absolutely nothing to do with which hemisphere you live in. I'm not sure where this myth first originated. The myth that water spirals out of the drain one way in the northern hemisphere and the other way in the southern hemisphere. I do know that I've come across a lot of students who believe it. So it's time to set the record straight. Is there an effect that could be an actual real science thing going on here? Oh, yeah, of course. It's called the Coriolis effect. The thing is, it's only observable on a large scale. If the Earth were a non-rotating planet, winds and currents would tend to flow from an area of high pressure to an area of low pressure. They would flow in a nice straight line. However, because the planet does rotate, moving objects appear to veer to the right in the northern hemisphere and to the left in the southern hemisphere. This is the Coriolis effect, the apparent deflection of moving objects when they are viewed from a rotating reference frame, such as the Earth. There are two reasons for the Coriolis effect to be, well, an effect. Firstly, the Earth rotates eastward. That's why the Sun rises in the east and sets in the west. Secondly, the tangential velocity of a point on the Earth is a function of latitude. This is a funky way to say that you're moving faster at the equator than you are at the poles. Tangential velocity is the speed at right angles to the surface of the Earth. It's essentially zero at the poles because all they're doing is spinning on the spot, and has a value of 1674 kilometers per hour at the equator. So, let's say you go old school and set up a cannon, one capable of firing a cannonball a really, really long way. If you fire it northward from a point on the equator, the cannonball would land to the east, or to the right, of its due north path. It would appear to be deflected to the right. This is because the cannonball was moving eastward, faster, being at the equator, than its target in the north was. If the cannon was fired towards the equator from the North Pole, the cannonball would, again, land to the right of its intended target. This time, the target area would have a greater eastward tangential velocity, and would have moved eastward before the cannonball reached it. Keep in mind, the cannonball would have flown in a straight line in both cases, and would only have appeared to veer off to the side. The same situation can be applied to the southern hemisphere, except in this case the cannonball would appear to be deflected to the left. So you see, the Coriolis deflection is related to the motion of the object, the motion of the Earth, and the latitude. It's proportional to the rotation rate, and because the Earth completes only one rotation per day, the Coriolis effect is actually quite small. It becomes noticeable only for motions occurring over large distances, hence your cannon would need to be able to fire a cannonball a really, really long way to observe the effect, or over long periods of time. Cannonballs take a while to arrive at their destination. Large-scale movements of air in the atmosphere? You bet. Water in the ocean? Absolutely. These can be affected by the Coriolis effect. But the direction in which water drains from your sink or your toilet? Nope. Blame that on the shape of the basin or the bowl, in addition to the angled placement of any water jets, etc. So there you go, the Coriolis effect. Well, that's the video done. If you liked it, brilliant. Hit the like button and leave me a comment too. Now you know what to do. Go hit that subscribe button. We'll see you next time.